As a continuation to my discussion on custom crystal and LC filters, let me clarify a little bit what that means in terms of frequency range. Custom crystal, quartz-based AT-cut crystals are used in crystal filters up to 200 megahertz using third overtone crystals, and up to 150 megahertz roughly using fundamental mode crystals. If we're going to have crystals that are 100 megahertz and higher, up to 150 megahertz, from a fundamental mode, those are all usually MESA, M-E-S-A, MESA-type crystal technology. MESA-type blanks are specially manufactured. We won't get into the details of those because that's just a whole nother subject. But the MESA crystals are specially manufactured blanks which allow for fundamental operation on the fundamental mode up to 150 megahertz. The MESA process allows for a lot less breakage of the crystal blank throughout the process when you use a MESA technology versus a standard crystal blank technology. So crystal filters can go up to 200 megahertz using third overtone crystals, or they can go up to 150 megahertz fundamental, all the way down to as low as 1 megahertz fundamental. On the LC filter product line, the LC filters are discrete components, inductors and capacitors, in an LC filter network. Based on the materials we might use, we can go anywhere from kilohertz all the way up to as high as 3 gigahertz, and sometimes beyond 3 gigahertz up to about 6 gigahertz. A couple other key differences between the two filter technologies right away when your customer's talking to you is related to the input power that each crystal type can handle. If your customer is talking about 0 dBm, which is 1 milliwatt, or 10 dBm, which is 10 milliwatts, and that's all the power that the filter is going to bring in from the input, right away you know that it's a crystal filter. You can handle the application with a crystal filter solution. Crystal filters are very low power filter devices. If the customer right away talks about multi-watts, 1 watt, 10 watt, 50 watt, 100 watt, 200 watt, this high power capability immediately should tell you that the application could very well be an LC filter, or it could be a DR ceramic filter, which we will talk about in another video. So power handling capability, milliwatts, it's usually going to be a crystal filter. Into the watts or tens of watts, it's going to be an LC filter. If you overdrive, if you send a watt or two through a crystal-based filter, basically you are overdriving the crystal, and more than likely the crystals are going to shatter. If there's 4 crystals used, maybe 1 will shatter, but that will basically eliminate the filter performance as a composite design. So even a slight overdrive of crystal filters, instead of 10 dBm, say the customer's driving with 12 or 13 dBm. Whenever you overdrive an AT-cut crystal, what occurs is you basically bring out the worst in the crystal. You bring out all the nonlinear properties. You may not bring all those nonlinear properties out at 25 degrees C. So you might be measuring the crystal parameters at room and everything looks good. But if you overdrive the crystal, maybe the nonlinearity in performance shows up in some of the crystal parameters over operating temperature. Now for LC filters, there's no crystals inside, so you can drive to very high powers. The difference, of course, is if you don't have a crystal, then instead of having a few thousand for Q, a loaded Q of say 3,000 or 4,000, you might have a loaded Q of 50 to 100 for an LC filter. So in other words, they're much lower Q, and therefore their bandwidth is very wide. So let's talk about that for a second. Bandwidth percentage. Usually you take the total bandwidth, the plus or minus so many kilohertz or megahertz, add it together, and divide by the operating frequency, or the center frequency. So if a crystal filter, for example, is plus or minus 35 kilohertz, 3 dB pass band, the total bandwidth is 70 kilohertz divided by, let's say the center frequency is 124.8 megahertz. So 70 kilohertz divided by 124.8 megahertz, and then you convert that to a percentage, is roughly 0.06%. Okay, so that's a narrow band or intermediate band crystal filter. We'll get more into that in a later time of the tape. But again, that's going to be for a crystal filter. You might get as high as 1% total bandwidth for a crystal filter application. For LC filters, you'll be anywhere from 2% up to 10%. Theoretically, you could get almost 100% of the total bandwidth pass band. Almost the entire pass band could be covered by, the entire frequency range could be covered in an LC filter. So much wider bandwidths. Usually you talk about plus or minus a few megahertz for LC filters, where your discussions are strictly limited to kilohertz in terms of the pass and the stop bands of crystal filters. Thank you.